This video explains the entire network design ribbon. First, there is the Settings group box. This controls under which circumstances relationships can be automatically created and is hence directly linked to the Generate Adjacencies group box. A prerequisite for these settings are either results from a block adjustment, in case that scans with no pre-orientations are given, or pre-orientations from other registration software or scanners with additional localization sensors. The parameters, maximum horizontal distance and maximum vertical distance, define the distance up to which a relation is automatically created. Therefore, horizontal and vertical distances are computed from every station to its neighbors. The checkbox cross-group only generates relations among stations that are associated to different groups. This function is particularly helpful to densify relations among groups which may contain data from different days of acquisition or scanners. Numerous functions to assemble a network based on pairwise registrations between stations are featured in the Generate Adjacencies group box. While they all have the same aim, their focus, and hence preferable use case, are different. In the following, all strategies will be introduced. Generate adjacencies from point identities. If point identities have been already created in the project, the algorithm assumes that stations containing the same target are also adjacent. Relations are automatically created for these stations. This function does not require pre-orientations and is typically used in projects with elongated characteristics such as tunneling. Generate adjacencies from station IDs. This function automatically generates relationships based on ascending station IDs and does not require pre-orientations. It is typically used in cases where no pre-orientations are given, in tunneling or staircases. Generate adjacencies from station datum. This function automatically generates relationships based on a scan's timestamp. It is closely related to the previous function and is used for point clouds whose file names are based on date and timestamps. Generate adjacencies from station positions. This function requires pre-orientations for the scans. These can either have already been created during import or they were created after a block adjustment. The function is controlled by the defined parameters in the Settings group box of the Network Design tab. It generates relations to all adjacent stations that are no further located than the maximum horizontal distance and maximum vertical distance. Generate adjacencies by triangulation. This function automatically generates relationships by means of a Delaunay triangulation. In contrast to the previous function, Generate adjacencies by triangulation typically creates a lot less relations. Due to the triangulation scheme, the reliability of the network should still be sufficient. This function is helpful when capturing wide-open spaces, e.g., big factory halls or tunnels. Generate adjacencies by corner matching. This function was designed for automatically computing the network graph without existing pre-orientations in locally restricted areas, such as individual flats. Corner matching, as the name suggests, first identifies corners based on detected planes. A difficult task with all matching algorithms is to determine corresponding information, which is why a novel descriptor was developed to characterize each corner. Note that corners are not limited to corners of rooms, but to all geometric configurations where three planes intersect in a sufficient configuration. This algorithm not only automatically generates relations between individual stations, but also calculates proximity values for pairwise registration, speeding up subsequent plane matching. Corner matching can be applied to individual groups or selected stations. It is recommended to apply the algorithm to scan sets whose geometric content is reasonably unique and does not contain repeating patterns. Generate adjacencies by AutoConnect. This function looks for overlapping planes among pre-oriented scans or orientations that stem from a block adjustment and checks if the geometric contrast is sufficient. Note that the settings maximum horizontal and vertical distance in the settings group box are considered. If the contrast is sufficient, then a pairwise registration is computed. If the translational precision sigma t is lower than n millimeters, no relation is created. The according setting can be found under Settings, Matching, Auto Connect. It is very useful in nearly all use cases. Note that this function can also be applied during plane detection, so that the network graph is gradually assembled. To achieve this, navigate to the Processes ribbon in the Settings and tick Auto Connect after plane detection. The matchmaker was designed to either visually inspect an existing relation or to visually generate relations in undocumented complex scenarios based on intensity images. The general idea is inspired by dating apps. Users browse through a set of intensity images on the quest for a matching partner. As soon as the matchmaker is started, a new panel appears below the graphic window. Two intensity images are displayed. The left and right arrow icons in the left or right image group box, respectively the arrow keys on the keyboard, move to the image of the previous or next station within the current group, while the up and down arrows move to another group. If the user wants to navigate to the image of a specific station, it can be either selected in the graphics window by clicking at Focus in the context menu or by using the drop-down menus for groups and stations. Displaying the images of an existing relation can be achieved by focusing using the context menu. If overlap between two scans has been identified based on the two images, a relation can be generated by clicking on the heart icon or by pushing the space key on the keyboard. The new relation is added to the adjacency graph, and the user can proceed with defining further relations. Note that it is also possible to browse through both images purely based on keyboard commands. Therefore, the highlighted setting in the Matchmaker ribbon needs to be chosen. Furthermore, the Matchmaker contains three group boxes. The image group box controls or interacts with the images. The swap image icon changes the images from left to the right image frame or vice versa. Clicking at the Digitize Points icon will allow to manually specify the location of a sphere, a checkerboard target, or a local point. Per default, the Matchmaker will illustrate all detected planes within a scan. Should a user want to analyze which planes were exactly used to compute pairwise registration parameters, the Hide Unmatched Planes button provides this functionality. This is particularly helpful in cases where something unexpected lead to a falsification of a pairwise registration, for instance, a geometric change that occurred in between scans. The Relation Group box controls and illustrates the status of relations between a pair of selected stations. The color of the depicted arrow denotes the current status of a relation, while the color scheme of the editing mode is applied. If no relation has been defined between two stations, the heart icon will be activated. Clicking at it will create a new relation. Activating the red cross will delete a selected relation. Once the Connect Manually group box is activated by clicking the hand icon, a user can manually define corresponding objects in both bitmaps. In the case of planes, only the approximate area and not exactly an identical point must be selected. Points can either be deployed by using already existing ones or by digitizing new points. At least 3 identities are required to be able to calculate a pre-transformation between the two stations. Note that pre-transformations can be computed solely based on point or plane identities, but also a combination thereof. Whether the selected combination is sufficient is indicated by the little traffic light man. If it is colored in green, the combination is sufficient, while it is insufficient once the icon is tinted in red. Clicking on the button with the traffic light man starts a pre-transformation based on the selected identities, followed by plane matching with all detected planes. The calculations are logged in the message window. If the calculation is not successful, further identities or other identities must be selected. By clicking the button with the green tick, the result is accepted and adopted. Users can also specify a sufficient geometric quality, so that relations are automatically accepted. The task of the matching group box is to provide functions for preparing or generating matches between planes or points. It contains 3 buttons that are associated to pairwise registrations based on planes or the point cloud, and 3 for matching point features. The plane matching button starts the homonymous process. If automatic matching is activated under the process's ribbon of the settings, it is not required to activate this function. However, it can be used to immediately force matching for a selected relation. Cloud-to-cloud matching can be used if the overlapping region between 2 scans does not feature any or just a few common planes. For instance, a scene that features a garden. Note that it is not a classical iterative closest point implementation, but our own take that detects and matches tiny planar features. The Pathfinder function can be used to generate starting values whenever a loop closes. Let us assume a case where 3 stations are already connected by 2 pairwise registrations, while a third one was just defined. The Pathfinder uses the existing registrations to generate starting values for the matching algorithm. It can also be automatically activated under the processor's ribbon of the settings. Note that this function is automatically carried out after every successful block adjustment. If point features have been detected and matched in external software, or if users have manually named identical points by using unique identifiers, the point matching via point IDs function can be used. It generates point identities based on the identifiers. Given the case that targets were additionally detected in Scantra, it is highly recommended to tick the option Use Station Name as Prefix in the sphere/checkerboard detection group box under the detection ribbon. The pairwise point matching function matches points between pairs of stations and requires at least 3 non-linear corresponding points. Once points are matched, a relation is created and starting values are assigned to it. This function is being typically used on stations without pre-orientations. The datum-dependent point matching function requires that all stations of interest need to be given in one common coordinate system. This prerequisite is satisfied after a successful block adjustment or if pre-orientations were imported. Initiating this function will either determine local or global point identities, respectively both. There is no requirement for a minimum number of identical targets between a pair of stations. Hence, it can also determine single target matches between stations. If this function should be used to connect stations to geodetic control points, then at least 3 point pairs need to be manually assigned. The checkboxes next to the button control which types of point identities are considered.